Happy Monday! Today we are going over algebra. When we're looking at these problems, we have three different options that we can use to solve them. So we're going to go over these in a small group as well, but just to cover them here, we can find patterns in our tables. We can plug in numbers straight to the equation and solve that way, or we can translate. If we want to translate a problem, we're starting with a word problem. So starting with words. And we want to end with an equation or an expression. So in this problem, we're starting with a table, not necessarily a word problem. So we're actually going to be using either finding patterns or plugging in. If I want to find a pattern in this table, I'm looking at something that seems clearly like addition or multiplication. And I'm trying to figure out, is this an additive table or a multiplicative table? So I see way over here, I see 11 to 88. So the number of shirts is 11 shirts. The cost of the shirts is $88. So I say, okay, well, from 11 to 88, I would have to multiply by 8. And I just want to know, is that true for every single section of my table? So if I wanted to get from 3 to 24, I could multiply by 8, and that would work. From 4 to 32, I could multiply by 8, and that would work. From 6 to 48, multiply by 8, and that would work. And 8 to 64, I could multiply by 8, and that would work. So because the entire table allows me to multiply by 8, to go from my S value to my C value, I'm looking for an equation that says I can take the number of shirts, so my number of shirts, which is S, multiply it by 8, and get the cost of shirts, which was C. So looking through here, I have this one is addition, and it couldn't be addition. This one, if it's in fraction form, S over 8, that's actually division when it's in fraction form like that. So I'm going to say, no, it can't be that one. This one has both a multiplication and addition. So no, I only want multiplication. And down at the bottom, we have C equals 8S. And remembering that this 8S actually means 8 times S. We're just taking that X out right here because it can get confusing and it can start to look like a variable. But when a number and a letter are right next to each other, it's still multiplication. If finding a pattern was a little bit more confusing, like if you're like, I didn't see that times 8 right off the bat, you can also plug in, so our second option, plugging in, we can plug in 3 to all of our equations and see what it would take to get 24. So if I plugged in 3 to my first equation, 3 plus 21 would equal 24. So it would work for the first set of values. But if I tried to go to the second set and do 4 plus 21, I wouldn't get 32. I should have gotten 25. So I know that this equation doesn't work. Same thing here. If I tried to take 3 and divide it by 8, I should not have gotten 24. I would have gotten some crazy decimal. So I know it's not this one. 7S plus 3, so I would take 3 times 7, so 21 plus 3. Would give me 24, so it works for that first one. But if we plug it into the second one, it would be 28 plus 3 would give me 31 instead of 32. So when we're plugging in, we have to make sure that we're plugging it into at least 2 values from the table, not just the first one, because they love to give us equations that only work for the first column of our table and not for the whole table. So we're looking for an equation that works for every single column or row in our table. Looking at this next one, the table below shows the relationship between the terms in a sequence. It gives us the term position, N, just meaning like where is this number in the sequence, which is just like a line. And then the value of the term. So it's saying that 8 is in first place, 9 is in second place, 10 is in third place, and 11 is in fourth place. Which description represents the information on the table? So we're just trying to figure out, okay, it says each term of the sequence is 7 more than its position. We're going to use a little bit of translate here and a little bit of plugging in. So each one of these sentences is telling us in words, it's giving us an equation. So I'm looking for, okay, 7 more. That would mean that we're adding 7. So am I adding 7? As I go down here, 1 plus 7 does equal 8, so it works for the first one. 2 plus 7 does equal 9, so it works for the second one, but we're going to check every single one. 3 plus 7 equals 10, and 4 plus 7 does equal 11. So yeah, we could say each term of the sequence is 7 more than its position. If we take the position and add 7, we would get the value of that term. All right. For our very last one, it asks us to look at the set of ordered pairs below. Which of the ordered pairs satisfies the rule y equals x plus 4? So if I'm taking my x value, remembering that we have x and then y, so my first value is always going to be my x. If I took x and added 4 here, I would get 4 plus 4 equals 8, so this one does work. If I take my x value, -2, and I added 4, I would get +2, so this one works. If I took 0 plus 4, I would get 4, so this one works. But if I took 10 plus 4, I should get 14. And this one says I would get 6. So we're going to say that D does not work. Looking at my answer choices, I'm arguing that A, B, and C work, but not D.